Our solar system hides worlds that defy every rule of planetary science. These are not planets, but moons, and their existence challenges everything we thought we knew. You are about to journey to 25 of the strangest of these alien landscapes. By the end of this tour, you will see our cosmic neighborhood not as a static museum, but as a theater of violent collisions, gravitational dances, and impossible oceans. We will visit a moon with erupting volcanoes fueled by a giant planet's pull, and another hiding a sea beneath its ice with secrets of its own. What single cosmic mystery do you find most compelling? Jupiter's first great defiance hangs in its orbit, a world of fire named Io. This is not a dead rock drifting in the cold of space, but a cosmic pressure cooker. Its surface is a nightmare of volcanic fury, painted in yellows, oranges, and reds by rivers of molten sulfur. Hundreds of active volcanoes constantly erupt, spewing plumes of gas and dust hundreds of miles into its thin sky, a spectacle visible from passing spacecraft as brilliant fountains against the blackness of space. This relentless activity makes Io the most volcanically violent place we have ever seen, and that is the central puzzle. Io is far, far too small and too distant from the Sun to have any internal heat left from its formation. By all rights, it should be a frozen, silent world, as geologically dead as our own moon. So what is the source of this endless inferno? The answer lies not within Io itself, but in the colossal dance it is forced to perform. Jupiter, a planet so massive it could swallow every other world in our solar system and still have room, exerts a gravitational pull of almost unimaginable strength. Io orbits so close to this giant that it is caught in a perpetual tug of war between Jupiter and its neighboring large moons, Europa and Ganymede. This relentless, rhythmic pulling stretches and squeezes the moon's interior like a ball of clay in an invisible fist. This process, called tidal heating, generates immense friction deep within Io's core. That friction creates the heat that melts its rock, powering the global network of volcanoes that constantly remold its surface, erasing craters almost as soon as they form. Imagine a world where the very ground beneath your feet is being kneaded by the hand of a planet, its internal fires stoked not by a nearby star, but by the gravitational symphony of its celestial neighbors. Io is a testament to the fact that in our solar system, a moon's story is never its own. It is a chapter written by the giant it orbits. The volcanic fires of Io are just the first act in Jupiter's gravitational drama. Look a little further out past those sulfurous plumes, and you find a world of a completely different, almost serene contradiction. This is Europa, a smooth, pale sphere crisscrossed with a web of rusty red cracks. At first glance, it looks like a cracked eggshell or a marble left too long in the cold. Its surface is one of the smoothest in the entire solar system, a vast frozen plain with barely a mountain range or a deep crater to be seen. This alone is a profound clue. On an ancient world, you expect a battered landscape, a record of billions of years of asteroid impacts. Europa's youthful face tells us its surface is constantly being renewed. Something is erasing the scars, something is actively reshaping this moon. That something is a global ocean. Beneath an ice crust perhaps 10 to 15 miles thick lies more liquid water than exists in all of Earth's oceans combined. This is the second great defiance. Europa is even smaller and colder than Io. By every conventional model, its core should have frozen solid eons ago. Yet here it is, hiding a warm, dark, salty sea. The engine, once again, is Jupiter's relentless gravity. Europa experiences the same tidal squeezing as its volcanic neighbor, just to a slightly lesser degree. Instead of melting rock to create volcanoes, this flexing generates just enough heat to keep a global layer of water in a liquid state, sandwiched between a frozen ceiling and a rocky seafloor. This creates an environment unlike any other we know. The surface ice is not a static lid. it is a dynamic, shifting crust. Those iconic cracks and jumbled regions scientists call chaos terrain are the scars of this activity. They are likely places where the ice has fractured, allowing subsurface slush or even water to well up and refreeze, creating a fractured, puzzle-like landscape. This process may also transfer chemicals from the surface down into the ocean below, and that is where the most thrilling possibility emerges. On Earth, we have found life thriving in the most extreme places, from scalding hydrothermal vents at the bottom of our oceans to within solid rock. Europa's dark ocean has all the key ingredients we believe life needs: liquid water, a source of chemical energy from tidal heating, and likely hydrothermal vents on its seafloor, and organic compounds. It is a sealed, sunless biosphere warmed from within. Imagining what might live there is the work of astrobiologists and dreamers. Perhaps simple microbial communities cluster around volcanic vents on the ocean floor, their biochemistry fueled by chemistry, not sunlight. Or perhaps in that eternal darkness, more complex organisms have evolved, navigating by sound or electrical fields in waters that have never known a dawn. Europa stands as a quiet, frozen vault, holding within it the profound and haunting question: are we alone in this vast cosmic ocean, or is life a story that gets told more than once? The promise of hidden oceans does not end with Europa. Journey further still from Jupiter's searing embrace, and you encounter a world so large it redefines the very word moon. This is Ganymede, a Titan in its own right, larger than the planet Mercury and nearly as wide as Mars. It is a world of profound and silent contradictions, holding secrets within its frozen heart that make it utterly unique in all the solar system. Its surface tells two stories. Vast, dark, ancient plains are scarred with countless craters, a testament to a history stretching back billions of years. But overlaid on this ancient canvas are brighter, younger regions marked by intricate grooves and ridges, as if some colossal force has stretched and torn the icy crust apart. This tells us Ganymede, too, has been geologically active, its face reshaped long after its birth, yet its most astonishing feature is invisible to the naked eye. Ganymede is the only moon we know of that generates its own magnetic field. This is a trait of planets, not moons. Think of Earth with its molten iron core churning like a dynamo, creating the protective magnetic shield that deflects harmful solar radiation and gives us the northern lights. For a small, icy moon to possess such an engine deep within its core is extraordinary. It means Ganymede must have a hot, molten, metallic heart, likely of iron, still swirling with currents after billions of years. How does a moon so far from the sun retain such fierce internal heat? The answer, once more, is a story of gravitational persuasion. While not as intense as on Io or Europa, Jupiter's tidal forces still flex Ganymede, helping to keep its interior warm and dynamic enough to power that planetary-scale magnetic heart. This creates a breathtaking celestial interaction. Ganymede's small, intrinsic magnetic field is completely embedded within the overwhelming magnetic bubble of Jupiter, the solar system's most powerful magnetosphere. The two fields clash and connect, funneling charged particles along invisible highways. Where these particles slam into Ganymede's thin atmosphere at its poles, they ignite brilliant, permanent auroras, rings of shimmering light that glow in ultraviolet against the darkness, a silent light show powered by the dance between a moon and its master. And beneath its complex, grooved shell, scientists are nearly certain Ganymede holds another secret, a vast subsurface ocean, likely sandwiched between layers of ice or nestled above its rocky mantle. This makes Ganymede a world of three distinct layers: a metallic core, a rocky shell, and an outer cloak of ice and water, a miniature planetary system in one. It is a place where the lines between moon and planet blur beyond recognition, a sovereign world in all but name, orbiting a king. But Jupiter's outer court holds a starkly different witness to cosmic history. Callisto, the fourth and outermost of these great moons, is a frozen archive, a world that seems to have slept through the solar system's most violent eras. Its face is the most heavily cratered surface we have ever seen, a testament to an ancient, unbroken bombardment. Each impact scar, from the tiny to the colossal, remains perfectly preserved like footprints in a dust that never settled. This is the key to its strangeness. While its siblings Io, Europa, and Ganymede were kneaded and heated into new forms, Callisto appears untouched, a primordial relic. Its surface is a simple mixture of dark rock and bright water ice, with none of the dramatic volcanoes, global oceans, or magnetic fields of the inner moons. So why did the gravitational drama that transformed its neighbors leave Callisto so profoundly asleep? The answer lies in its orbit and its construction. Callisto orbits just far enough from Jupiter to escape the intense, resonant gravitational tug of war that heats the inner moons. Its dance is more solitary, more serene. More importantly, scientists believe Callisto was never fully differentiated. That is a technical term for a simple but profound idea. The heavier materials, like rock and metal, never fully sank to form a dense core, and the lighter ices never fully rose to form a distinct mantle. Instead, Callisto is a mixed, homogeneous ball of ice and rock, like a cosmic fruitcake that was never properly baked. This uniform interior does not flex efficiently under tidal forces. Without distinct layers to rub against each other, it generates very little internal friction and thus very little heat. It remained cold and solid, a passive recorder of every asteroid and comet that ever struck it. The most dramatic entry in that record is the Valhalla impact basin. This is not a simple crater, but a series of concentric rings rippling outward for nearly 2,000 miles from the central point of impact. It looks like a giant stone was dropped into a pond of ice, freezing the ripples in place for all time. Valhalla tells the story of a cataclysm so immense it sent shockwaves through the entire moon, yet Callisto's rigid, frozen body simply registered the blow and held the shape. This ancient, cratered world offers a crucial counterpoint. It shows us what the other moons might have been, had they not been caught in Jupiter's fierce gravitational embrace. Callisto is the untouched control sample in a grand experiment, proving that in the same celestial neighborhood, destiny is written not just by where you are, but by what you are made of and how you are stirred. Yet as we leave Jupiter's frozen archives behind, a far more alien echo of Earth awaits at Saturn. Titan is a world that holds up a distorted mirror to our own planet, familiar in its processes but utterly alien in its substance. This is not a barren rock or a simple ball of ice. Titan is shrouded in a thick, hazy atmosphere of nitrogen, so dense that standing on its surface would feel like standing at the bottom of an ocean of air. That orange smog, created by sunlight breaking apart methane high above, hides a landscape of profound and active complexity. Here, the cycle of rain, rivers, lakes, and seas plays out in a deep freeze. But the liquid is not water. On Titan, with surface temperatures plunging to -290 degrees Fahrenheit, water is as hard as granite. Instead, the role of water is played by liquid methane and ethane, hydrocarbons that flow like gasoline. The Cassini spacecraft peered through the haze with radar, revealing a world sculpted by these alien fluids. It found vast, dark seas like Kraken Mare, larger than Earth's Caspian Sea, nestled among rolling hills and valleys. It mapped river channels that cut through the terrain, draining into delta-like formations. It even captured evidence of rain clouds and methane storms, proving this is a world with active weather. This cryogenic hydrological cycle makes Titan the only place besides Earth known to have stable liquid on its surface, a fact that reshapes our understanding of what makes a world dynamic. But the strangeness deepens. The complex chemistry happening in Titan's atmosphere and on its surface is a kind of frozen prelude to life. Sunlight and energetic particles from Saturn's magnetosphere zap the methane and nitrogen in the upper atmosphere, creating a soup of more complex organic molecules. These compounds, including things like benzene and hydrogen cyanide, slowly drift down like snow, coating the surface in a layer of organic sludge. Imagine tar-like dunes made of plastic sand stretching for miles, or lakes of liquid methane evaporating under a dim sun, leaving behind bathtub rings of organic residue. This ongoing planet-wide chemistry experiment uses the same basic elements that, on a warmer, water-rich Earth, led to the building blocks of biology. Triton shows us a different pathway, a road not taken, where the recipe for complexity is written in hydrocarbons instead of sugars and amino acids. It is a laboratory for understanding the chemical steps that may precede life anywhere in the cosmos, a hazy, orange world where the very air is busy making the stuff of potential futures. But the true jewel of Saturn's system is not its largest moon, but one of its smallest. Enceladus is a brilliant white pearl of ice, only about 300 miles across, so tiny it could fit within the borders of Arizona. By all logic, this little world should be a dead, frozen marble, a silent testament to the cold of deep space. Its surface is astonishingly bright, reflecting almost all the sunlight that hits it because it is constantly being recoated with fresh, clean ice. And that is the first clue to its impossible nature. Something is actively cleaning and renewing this moon. The revelation came when the Cassini spacecraft flew past Enceladus and witnessed a sight that stunned planetary scientists. From a series of warm, parallel fractures nicknamed tiger stripes at its south pole, enormous geysers were erupting into the void. These were not gentle plumes, but furious jets blasting water vapor, ice particles, and simple organic molecules hundreds of miles into space. They form a magnificent, shimmering halo around the little moon, a constant eruption of its inner ocean into the darkness. This material does not simply fall back down. It escapes Enceladus's weak gravity entirely, going on to form Saturn's faint but vast E-ring, a ring of fine ice dust that traces the moon's entire orbit. Enceladus, a mere speck, is feeding an entire planetary ring. The energy required to power these continuous eruptions is enormous. The source, once again, is tidal heating. As Enceladus orbits Saturn, the giant planet's gravity squeezes and flexes it, but with a crucial twist, its orbit is slightly elliptical, not a perfect circle. This means the strength of the squeeze changes constantly, pumping friction and heat into its core with every trip around the planet. This heat is enough to maintain a global liquid water ocean beneath an ice shell perhaps 20 miles thick, with the warmest, most active region right at the South Pole. Cassini did more than just photograph the plumes, it flew directly through them. Its instruments tasted the spray, and the data revealed a second, more profound shock. The icy particles were rich in salts like sodium and potassium and tiny grains of silica. The chemistry pointed unmistakably to one conclusion. On the floor of Enceladus's dark ocean, where the rocky core meets the water, hydrothermal vents must be active. These are like the deep sea vents on Earth, where superheated, mineral-rich water spews from the seafloor. The silica grains were the smoking gun, a mineral that forms in hot water on Earth. This transforms Enceladus from a curious moon into a sanctuary. It has all three ingredients scientists deem essential for life: liquid water, a source of chemical energy from those hydrothermal vents, and organic building blocks which were detected in the plume. The ocean is in direct contact with a rocky, chemically rich seafloor, a perfect recipe for the kind of chemistry that could spark and sustain microbial life. Picture a world where the entire sky is a solid ceiling of ice, under which a global sea churns in perpetual darkness. On its deepest abyssal plains, hot, mineral-laden water billows from chimney-like structures, creating oases of warmth and chemical potential. Could simple organisms cluster there, feeding on the energy from hydrogen or methane bubbling up from the moon's heart? Enceladus offers us the most accessible test. Its ocean is literally spraying itself into space, handing us a sample. A future spacecraft could fly through the plume, capture that ice, and analyze it for the unmistakable signatures of life, all without ever landing or drilling. This tiny, brilliant moon, by screaming its secrets into the void, may hold the quietest answer to our oldest question. Yet Saturn has a moon that offers a mystery written in pure black and white. Iapetus is a cosmic paradox, a world divided against itself. One hemisphere is as dark as fresh asphalt, absorbing almost all the sunlight that touches it. The other is as brilliant and reflective as freshly fallen snow. This stark, two-toned face makes it look less like a natural moon and more like a celestial yin-yang symbol carved from ice and shadow. The dividing line between the dark and light regions is razor-sharp, an unnatural border that defies simple explanation. How can a single world wear two such radically different faces? The leading theory is a story of cosmic theft and slow-motion painting. Iapetus orbits far from Saturn, on a tilted path that takes it beyond the realm of the planet's major rings and inner moons. Out there, it swings through the orbital path of a much smaller, darker moon called Phoebe. Phoebe is a captured asteroid, a dark, dusty object. As it is bombarded by tiny micrometeoroids, it sheds a faint ring of its own dark debris. Iapetus, plowing through this tenuous cloud like a car driving through a dust storm, collects the material on its leading hemisphere, the face that always points forward in its orbit. The dark coating, once it begins to form, triggers a runaway process called thermal segregation. The dark areas absorb more sunlight and grow warmer. This warmth causes any exposed water ice nearby to evaporate. The vapor then travels across the surface and recondenses on the colder, brighter areas, making them even brighter and icier, which in turn makes the dark areas even darker and warmer. Over eons, this process could have amplified a slight dusting into the profound, shocking contrast we see today. But Iapetus holds a second, equally bizarre secret. Straddling its equator, running over 800 miles long and rising 12 miles high in places, is a colossal ridge. This mountain chain gives the moon the distinct appearance of a cosmic walnut or a squashed sphere with a seam. In some sections, this ridge is broken by individual peaks that stand like lonely, monumental towers. No one is entirely sure how this ridge formed. It could be frozen remains of a ring system that collapsed onto the moon early in its history, or it might be the scar of a time when Iapetus spun much faster, its icy crust buckling under the centrifugal force before it slowed and locked one face forever toward Saturn. Together, the two-toned face and the equatorial ridge make Iapetus one of the most visually strange and geologically puzzling objects in our solar system, a world that seems assembled from the pieces of two different puzzles. From the stark duality of Iapetus, we drift inward to encounter a moon that seems to have no orientation at all. Hyperion is a cosmic oddity, a world that refuses to follow the rules of motion that govern every other major moon in our solar system. It is not a sphere, but a lumpy, potato-shaped rock about 250 miles across, and its surface resembles a gigantic sponge or a piece of pumice stone that has been violently pummeled. Deep, dark pits cover its face, some stretching for miles and plunging into profound shadow. This porous, cratered landscape is the first clue to Hyperion's bizarre nature. Its density is so low that it must be mostly empty space, a rubble pile of ice and rock held together loosely by gravity. Scientists believe it is the remnant of a catastrophic collision, a larger moon shattered in the distant past, with the fragments loosely reassembling into this fragile, cavernous structure. But its true strangeness is not in its shape but in its motion. Hyperion tumbles, unlike Earth's moon, which spins predictably on its axis, or even most other moons with stable rotations. Hyperion's spin is chaotic. There is no fixed North Pole. Its axis of rotation wobbles so dramatically and unpredictably that you could never set a clock by its days. One moment, its North Pole might point toward Saturn. The next, it could be pointing wildly into space, all while it continues its eccentric orbit. This chaotic tumble is a direct result of its irregular shape and the powerful, uneven gravitational tugs from the giant planet Saturn and its massive moon Triton, which orbits nearby. It is a moon perpetually off balance, caught in a gravitational dance it can never master. This endless tumbling has profound effects on its surface. Because Hyperion presents every part of itself to the sun at different times, there is no consistent pattern of warming or cooling. Sunlight strikes the deep pits at strange, shallow angles, leaving some in permanent, super-cold shadows where volatile materials like frozen methane or carbon dioxide might linger as black, tarry deposits. The Cassini spacecraft flying past this chaotic world captured its spongy surface in eerie detail, revealing a texture unlike any other, a celestial fossil of ancient violence. To stand on Hyperion would be an experience of profound disorientation, with the rings of Saturn lurching across a jagged sky in no discernible pattern, and the very ground beneath your feet a fragile lattice of ice and shadow. It is a world without rhythm, a testament to the enduring chaos that can linger from a single, forgotten impact billions of years ago. While Hyperion tumbles in chaotic silence, another of Saturn's moons presents a wound so vast it defines the entire world. Mimas is often called the Death Star moon, and one glance reveals why. A single, colossal crater named Herschel dominates its face, with a central peak rising from the basin like the focused lens of that fictional superweapon. The resemblance is so uncanny it feels almost intentional, a cosmic joke written across 800 million miles of space. But this is no cinematic construct. It is the scar of a real, ancient catastrophe that came perilously close to absolute annihilation. Herschel crater is 80 miles wide, nearly a third of the entire diameter of Mimas itself. To scale, an equivalent impact on Earth would create a crater over 2,500 miles across, swallowing continents. The impactor that struck Mimas must have been huge, likely shattering on contact and blasting debris across the Saturn system. The shockwaves from that collision would have raced through the entire moon, meeting on the far side and likely causing massive fractures. The fact that Mimas is still here in one piece, a coherent sphere, tells scientists the impact was just below the threshold of total disintegration. It was a glancing blow from oblivion. The survival of this crater is a puzzle in itself. Mimas is a small, icy world, only about 250 miles across. In the billions of years since that impact, why hasn't the icy surface slowly flowed and softened, smoothing over this monstrous scar like a healing wound? The answer is cold and simple. Mimas is geologically dead. It lacks any significant internal heat source from tidal forces or radioactive decay. Its surface is frozen solid, a rigid shell preserving every ancient impact like a museum display. The Herschel crater is not healing, it is merely waiting, a permanent monument to a single, shattering moment in time. Yet recent observations have introduced a tantalizing wrinkle into this story of a dead world. Precise measurements of Mimas's rotation revealed a tiny, unexpected wobble or libration as it orbits Saturn. This subtle rocking is larger than models predict for a simple, solid ball of ice and rock. It suggests something irregular lies within. One compelling explanation is that Mimas has a football-shaped, elongated core, a frozen relic of its formation. Another, far more thrilling possibility is that this wobble could be caused by a global subsurface ocean sloshing beneath 20 miles of ice. This seems ludicrous for such a small, cold, heavily cratered moon, a world that shows no surface signs of the cracks or renewing activity we see on Enceladus. But calculations show that even a modest amount of tidal heating from Saturn, focused in just the right way, could maintain a thin liquid layer between the ice and the rock. If true, it would mean that the solar system's most obvious symbol of cosmic violence might secretly cradle a hidden sea, a profound contradiction hidden behind the face of a battle station. Far from the ordered rings and inner moons, Saturn's gravity holds a wanderer from the outer dark. Phoebe is an ancient traveler, a moon that moves to the beat of a different cosmic drum. While nearly every other major moon in the solar system orbits its planet in the same direction the planet spins, Phoebe does the opposite. It circles Saturn on a retrograde, tilted, and distant path, a clear sign it was not born here. This moon is an immigrant captured long ago by the giant planet's gravity, likely snatched from the vast, icy reservoir of the Kuiper belt beyond Neptune. That origin story is written across its dark and battered face. Phoebe is not a smooth sphere, but an irregular, lumpy world about 130 miles across, shaped more like a potato than a planet. Its surface is one of the darkest in the solar system, as black as charcoal, absorbing almost all the sunlight that touches it. This is not the clean, reflective ice of Enceladus, but a surface coated in a thick layer of dark organic material and dust, a tar-like blanket that has settled over eons. Heavily cratered from countless ancient impacts, Phoebe's landscape is frozen violence, a testament to its long journey through the chaotic outer solar system. The Cassini spacecraft's flyby revealed a world of stark contrasts, with bright ice exposed in the steep walls of craters, gleaming against the pervasive darkness like flashes of bone in deep earth. This composition is a time capsule. Phoebe is a mix of water, ice, rock, and complex carbon-rich compounds, a primitive recipe from the very dawn of the solar system. Studying it is like holding a piece of the original building material from which the outer planets and their moons coalesced 4.5 billion years ago. Its capture by Saturn was a gentle theft on a cosmic scale. Likely drifting inward from the Kuiper belt, Phoebe passed too close to the young, massive planet. Saturn's gravity reached out, lassoed it, and bent its path into a permanent backward orbit. This event not only gave Saturn an exotic outer satellite, but it also set the stage for one of the system's other great mysteries. Scientists believe the dark dust that slowly erodes from Phoebe's surface, peppered by micrometeoroids, creates a faint, invisible ring of debris. It is this tenuous ring of primordial grit that slowly paints the leading face of Iapetus, the two-toned moon we met earlier, turning one hemisphere as dark as night. So Phoebe, this captured wanderer from the frozen frontier, is not just a relic itself, it is an active artist using its own ancient substance to stain another world. The journey from Saturn's captured wanderer leads us to a world that seems assembled by a celestial mad scientist. Uranus, a pale blue giant tipped on its side, holds a moon so bizarre it defies all conventional geology. Miranda is a Frankenstein's monster of a world, a patchwork quilt of terrain stitched together by gravity after a cataclysm. Its surface, as glimpsed by the Voyager 2 spacecraft in 1986, is a chaotic jumble of mismatched parts. You can see vast, rolling plains crisscrossed with grooves, right next to regions of intense, jagged ridges and deep, dark canyons. It looks as if someone took the pieces of 3 or 4 different moons, shattered them, and then glued them back together without any instructions. The most striking features are its coronae, enormous ovoid regions marked by concentric patterns of ridges and troughs. These features, unique to Miranda, resemble the racing stripes on a giant frozen egg. They are unlike anything seen on any other moon, and their origin remains one of the great unsolved puzzles of the Uranian system. Then there are the cliffs. Miranda boasts Verona Rupes, a fault scarp that is one of the tallest known cliffs in the solar system. From base to top, it soars for an estimated 12 miles, a sheer vertical or near vertical drop that would make the face of El Capitan on Earth look like a gentle slope. If you were to stand at its edge, the bottom would be lost in shadow and haze, a dizzying plunge into the heart of this fractured world. How does a moon only about 290 miles across, smaller than the state of Arizona, come to possess such dramatic, varied, and utterly chaotic terrain? The leading theory is as violent as the landscape suggests. Scientists believe that in the distant past, Miranda was struck by a colossal impactor, an object so powerful it completely shattered the moon into fragments. Instead of drifting apart forever, those pieces, held by their mutual gravity, began to slowly dance back together. Over millennia, they reassembled, but not into a neat, layered sphere. The chunks of rock and ice came together haphazardly, like a puzzle solved by a blindfolded giant. Denser, rocky material from the core might have ended up next to lighter, icy crust from another fragment. This chaotic accretion created the insane patchwork we see today, with different geological provinces slamming into one another, creating the towering cliffs and bizarre coronae in the process. It is a world born from absolute destruction and remade by the patient, indifferent hand of gravity, a permanent monument to its own violent rebirth. The chaotic patchwork of Miranda is a story of destruction and rebirth, but Neptune holds a moon whose very existence is a countdown to a final, spectacular end. Triton is a world of profound and chilling contradictions, a captured giant moving in the wrong direction. It is the only large moon in our solar system that orbits its planet backwards, a retrograde path that screams its alien origin. This frozen sphere, slightly larger than Pluto, was almost certainly not born alongside the blue ice giant Neptune. Instead, it is a refugee, a king of the distant Kuiper belt that drifted too close and was ensnared by Neptune's gravity in an ancient celestial ambush. That capture was violent, and it sealed Triton's fate. The orbit it was forced into is not stable. Like a satellite in a slow, decaying spiral, Triton is gradually being pulled closer to Neptune by relentless tidal forces. Billions of years from now, this inward march will likely end in one of two spectacular finales. Either the moon will be torn apart by gravitational stress, forming a glorious new ring system around the planet, or it will crash directly into Neptune's atmosphere in a cataclysm of ice and gas. For now, it hangs in that distant sky, a prisoner on a very long leash. Its surface is one of the coldest places we have ever measured, with temperatures plunging to -390 degrees Fahrenheit, only about 30 degrees above absolute zero. At such cold, most gases freeze solid, and yet this is not a dead world. The Voyager 2 spacecraft, humanity's only visitor to this distant realm, witnessed something astonishing: active geysers. Dark, dusty plumes were seen erupting from the icy surface, rising 5 miles high before being caught by a thin, weak wind and streaking across the landscape as dark streaks. These are not water geysers like on Enceladus. On Triton, the erupting fluid is nitrogen. The mechanism is a delicate dance of extreme cold and faint sunlight. Triton has a thin atmosphere of mostly nitrogen with a touch of methane. When the distant sun warms dark, dusty ice just enough, the frozen nitrogen beneath the surface sublimates, turning directly from a solid into a gas. This pressurized gas builds up until it ruptures the overlying ice, blasting a fountain of dark dust and vapor into the tenuous air. It is a cryogeyser, a cold fountain powered by the faintest whisper of solar warmth on the most frigid of materials. The landscape these geysers streak across is just as strange. Vast regions of Triton are covered in what scientists call cantaloupe terrain, a bizarre, dimpled texture of intersecting ridges and valleys that indeed looks like the skin of a melon. This is likely the result of the icy crust repeatedly melting and refreezing over eons. The surface itself has a pinkish hue, a tint likely caused by methane ice being irradiated by the sun and cosmic rays, transforming it into complex, reddish organic compounds called tholins. So we have a captured world orbiting backwards on a death spiral, so cold that air falls as snow, yet alive with erupting geysers under a pale pink sky. Triton is a monument to temporary activity in a permanent freeze, a vibrant prisoner counting down the millennia until its final, beautiful destruction. The slow death spiral of Triton was not the only act of cosmic violence in Neptune's past. Its gravity also ensnared a moon that now dances to a frantic, lopsided beat. Nereid, Neptune's third largest moon, follows the most eccentric orbit of any major satellite in our entire solar system. This is not a neat, circular path, but a wild, elongated ellipse that sends it on a dramatic journey of extremes. At its closest approach, or periapsis, Nereid screams past Neptune at a distance of just over 850,000 miles. But then it swings outward, reaching an astounding 5,900,000 miles away at its farthest point. To visualize this, imagine a moon that 1 month is relatively close to its planet, and half a year later is so distant it is barely held by gravity's tether at all. This extreme fluctuation is the key to its story. Such a chaotic orbit is almost never the result of a peaceful birth. It is the signature of a profound disruption, a gravitational scar. The prime suspect for this cosmic crime is the capture of Triton itself. When that giant Kuiper belt object was snared by Neptune's gravity billions of years ago, the event would have been catastrophic for the existing system. It would have plowed through any primordial cloud of moons and debris like a bull in a china shop, scattering objects into wildly new paths. Nereid is likely a survivor of that ancient chaos, a native moon that was violently kicked into its eccentric new orbit by Triton's dramatic entrance. Alternatively, it could be another captured object itself, an asteroid or Kuiper belt refugee that was just barely caught, forever doomed to this lopsided dance. Our only close-up glimpse came from Voyager 2 in 1989, and it was fleeting and distant. The probe saw a tiny, faint point of light, too far away to resolve any surface details. From that data, we know Nereid is an irregular, potato-shaped world, likely about 210 miles across on its longest axis. Its surface is very bright, suggesting it is covered in water ice, but its color is neutral gray, hinting at a different, perhaps more primitive composition than the icy moons born around Neptune. It takes this wanderer 360 Earth days to complete just one of its lopsided orbits around the planet. For most of that long year, it is a lonely, distant speck, a silent witness to the blue giant and its doomed backward orbiting king. Nereid's wild path is a permanent record of a system upended, a moon forever tracing the elliptical evidence of a past cataclysm. But the story of captured worlds and eccentric orbits is not confined to the giants. At the very edge of the classical solar system, we find a dance of equals that redefined a planet. Pluto and its largest moon, Charon, are not a king and subject, but a pair of icy partners locked in a graceful, intimate ballet. They are so close in size that the center of their mutual orbit is not inside Pluto, but in the empty space between them. This makes them the solar system's premier binary dwarf planet system, a double world forever facing one another across the void. The New Horizons spacecraft's flyby in 2015 revealed Charon to be a world of stunning and unexpected complexity, a place of canyons, plains, and mysteries that rival those of any planet. One of the most striking features is a vast equatorial canyon system, Serenity Chasma, stretching over 1,000 miles long and plunging up to 5 miles deep. To scale, this gash would span the entire width of the United States and reach over 4 times deeper than the Grand Canyon. This titanic scar hints at a dramatic past, likely formed when a subsurface ocean of water and ammonia froze long ago, expanding and cracking the moon's icy crust like an overfilled bottle. This leads to the captivating possibility that Charon, this distant, frozen companion, may once have harbored a liquid layer beneath its surface, a fleeting oasis of warmth in the deep freeze of the Kuiper belt. Yet not all of Charon is ancient and fractured. The spacecraft also revealed vast, smooth plains south of the canyon, informally named Vulcan Planum. This region is noticeably less cratered, suggesting a relatively young surface that was resurfaced by some form of icy volcanism or cryovolcanism in the geologically recent past. Perhaps slushy water-ammonia mixtures erupted from below, flooding the landscape and smoothing over the old scars. But the most visually striking feature is Charon's north polar cap, a distinct rusty red spot nicknamed Mordor macula. This coloration comes from tholins, complex organic molecules created when methane from Pluto's thin atmosphere escapes, is captured by Charon's gravity, and then frozen at the eternally cold pole. There, cosmic radiation and solar ultraviolet light cook the simple methane into a reddish, tar-like sludge. It is a direct chemical connection between the two worlds, a stain from its partner. And that partnership is absolute. Pluto and Charon are tidally locked, not just as moon to planet, but mutually. Just as our moon shows only one face to Earth, Pluto and Charon show only one face to each other. From the surface of Pluto, Charon hangs motionless in the sky, a giant marbled companion that never rises or sets. From Charon, Pluto looms equally fixed, a vast, creamy disk streaked with a bright heart-shaped glacier. Their dance is so balanced that a day on Pluto is exactly the same length as Charon's orbit around it. They whirl through the darkness as a single, inseparable unit, a testament to the fact that in the lonely reaches of the outer solar system, even a dwarf planet can have an equal. Mars, the red planet, does not have grand, icy moons with hidden oceans. Instead, it is attended by two tiny, dark, and misshapen companions that look more like potatoes than worlds. Phobos and Deimos are cosmic runts, so small and irregular they seem almost like afterthoughts against the vast, rusty backdrop of their planet. Their very presence is a puzzle, as their appearance and behavior defy the typical story of moon formation. Unlike Earth's large, spherical moon born from a colossal impact, or the icy giants orbiting Jupiter and Saturn, these two look exactly like asteroids. And that is the leading theory. They are captured asteroids, ancient wanderers from the main belt between Mars and Jupiter that strayed too close and were snared by the planet's gravity billions of years ago. Their shapes are lumpy and elongated, their surfaces are dark and heavily cratered, and their densities are so low they are likely porous rubble piles, barely held together. From the surface of Mars, they present a starkly different sky. Deimos, the outer and smaller moon, appears as little more than a bright star drifting slowly across the heavens. Phobos, however, is a dramatic sight. It orbits so close and so fast that it rises in the west and sets in the east, crossing the Martian sky in just about 4 hours. It appears as a distinct cratered disk, but it is still too small to fully eclipse the Sun, creating only a swift, moving shadow. Yet this close orbit is a death sentence. Phobos is caught in an inescapable spiral. Tidal interactions with Mars are slowly but relentlessly dragging it inward. In several tens of millions of years, its fate will be sealed. It will either cross the Roche limit, the point where a planet's gravity overcomes a moon's own structural integrity, and be shredded into a magnificent, temporary ring of debris around Mars. Or it will continue its plunge and crash directly into the Martian surface in a cataclysmic impact that will scar the planet for eons. This doomed trajectory makes Phobos a moon on borrowed time, a temporary fixture in the Martian sky with an expiration date. Adding to its mystery are the strange, parallel grooves that score its surface. These linear chains of pits and troughs look like stretch marks or the scars of deep internal fractures. One compelling explanation ties directly to its grim future. As Phobos is pulled inward, the increasing tidal stress from Mars may be causing its fragile, rubble pile interior to slowly deform, cracking the surface from within. Another theory suggests the grooves are chains of secondary impact craters, formed when debris ejected from a massive, ancient crater on Phobos, the Stickney crater, rained back down across its surface. The debate continues, a reminder that even these small, dark worlds hold secrets about the forces that shape celestial bodies. They are celestial interlopers destined for destruction, silently tracing their final orbits above the red sands. Our own moon, the familiar companion of our night sky, is perhaps the greatest cosmic anomaly of them all. Its serene, cratered face hides a past of unimaginable violence, a birth so catastrophic it shaped the destiny of our entire planet. The mystery begins with a simple observation: the moon is far too big. For a rocky planet like Earth, our moon is a giant, roughly 1/4 of Earth's diameter. Compare this to Mars, where the largest moon, Phobos, is a mere speck. This disproportionate size has no parallel in the inner solar system, and it demands an extraordinary explanation. Furthermore, when Apollo astronauts brought back lunar rocks, scientists made a startling discovery. The moon's chemical fingerprint, the precise ratios of different oxygen isotopes, is virtually identical to Earth's mantle. It is as if the moon was made from the very same material as our planet's outer layer, a clue that points directly to a shared origin. The elegant, if terrifying, theory that ties these anomalies together is the giant impact hypothesis. Picture the early solar system, a chaotic shooting gallery of newborn planets. Around 4.5 billion years ago, a Mars-sized protoplanet scientists have named Theia, after the mythical mother of the moon goddess Selene, was on a collision course with the young Earth. The impact was not a gentle merging. It was a glancing blow of apocalyptic force, striking at an angle and utterly obliterating Theia. The energy released vaporized both Theia and a significant portion of Earth's mantle, hurling a colossal cloud of superheated rock and vapor into orbit around our devastated planet. In the fiery aftermath, this donut-shaped ring of debris, a mix of material from both worlds, began to cool and coalesce. Within perhaps just a single century, gravity pulled this material together to form our moon. This explains the isotopic similarity. The moon is primarily made from the mantle of Earth and the shattered remains of Theia, blended together in that primordial furnace. The impact also solved other puzzles. It likely gave Earth its fast rotation and tilted axis, which gives us our seasons. And it explains the moon's surprising lack of a large iron core, as most of the dense metallic material from both bodies remained within the reformed Earth. This story is not over. The moon continues to drift away from us at a rate of about 1.5 inches per year, a slow recession measured by laser reflectors left by the Apollo missions. Billions of years ago, it loomed much larger in our sky, and Earth's days were much shorter. This gentle, ongoing departure is the final echo of that ancient cataclysm, a permanent reminder that our most familiar celestial neighbor is the product of the most violent day in our world's history. The violent birth of our own moon set a precedent for celestial chaos, but Jupiter's inner sanctum holds a relic that tells a different story of creation. Amalthea is a small, red, potato-shaped world, a celestial oddball orbiting so close to Jupiter it is bathed in the planet's lethal radiation. This is not a smooth sphere, but a lumpy, elongated rock, about 150 miles long on its longest axis, tumbling through space. Its most striking feature is its color, a deep, rusty red that is brighter than any other surface in the Jupiter system. This hue likely comes from sulfur dust, blasted off the volcanic moon Io, and then painted onto Amalthea by Jupiter's powerful magnetic field, like a cosmic artist using a moon as a canvas. But Amalthea's true mystery is not what it looks like, but what it feels like. Measurements from the Galileo spacecraft revealed something astonishing. This tiny moon actually radiates more heat than it receives from the distant sun. It is glowing with its own internal warmth. For a small, inert rock, this should be impossible. The explanation lies in its terrifying environment. Amalthea orbits deep within Jupiter's crushing magnetic field, a maelstrom of charged particles. As this metallic and rocky moon sweeps through this field, it acts like a conductor moving through a giant magnet. This motion generates powerful electrical currents within Amalthea itself, and as electricity flows through resistive material, it creates heat through a process called induction heating. Essentially, Jupiter is cooking its inner moon from the inside out with invisible magnetic forces. This constant bath of radiation and heat has another effect: it erodes the moon. Amalthea is slowly shedding its surface material, contributing tiny dust particles to one of Jupiter's faintest ring systems, the Gossamer ring that bears its name. Imagine a world that is both painted and slowly sandblasted by the environment of its planet, glowing with stolen energy as it feeds its own substance back into the system. Amalthea is a prisoner of Jupiter's power, a testament to how a giant planet can physically shape and even heat the small worlds that dare to orbit too close. Jupiter's gravitational reach extends far beyond its famous Galilean moons, into a realm of dark and ancient wanderers. Among these distant captives, one stands as a king of the lost. Hyperion is the largest of Jupiter's irregular, prograde outer moons, a dark, lumpy world that did not form alongside the giant planet. It is an immigrant, almost certainly a captured asteroid from the main belt between Mars and Jupiter, now bound forever to a new master. Observations reveal a surface as dark as coal, reflecting only a tiny fraction of the sunlight that hits it, a classic trait of carbon-rich C-type asteroids. This darkness is a frozen memory of its birthplace in the outer asteroid belt, a primitive, unaltered piece of the solar system's original building material. But Hyperion is not alone in its exile. It is the namesake and gravitational anchor for an entire family, the Hyperion group. This is a cluster of at least 5 smaller moons, all sharing strikingly similar orbits, tilted and distant from Jupiter. They move together like a school of fish in a vast, dark ocean, tracing elongated paths around the planet. This clustering is the key to their story. These moons were not captured one by one through random chance. Instead, the leading theory suggests a single, larger parent body, perhaps an asteroid 60 miles across or more, was captured by Jupiter's gravity in the solar system's chaotic youth. Then, in a later collision with another wandering object, this parent body was shattered. The fragments held by Jupiter's immense pull did not escape. Instead, they remained in orbits very close to one another, a family of debris from a single, ancient breakup. Hyperion is the largest surviving remnant of that catastrophe, the patriarch of the group. Studying these clustered orbits gives us a direct window into the violence and dynamism of the early solar system. It was an era of constant bombardment and gravitational shuffling, where small worlds were routinely captured, shattered, and rearranged by the growing giants. The Hyperion group is a fossilized snapshot of that process, a direct lineage from a single capture event. Their dark, primitive surfaces have been preserved in the deep freeze of space, largely untouched by the geological forces that reshape inner moons. They are time capsules holding chemical secrets about the conditions in the primordial asteroid belt, before Jupiter's gravity scattered much of that material across the solar system. Visualizing this family reveals the scale of Jupiter's domain. Animations show these tiny, dark specks tracing their wide, tilted circles far beyond the orderly orbits of the large icy moons. They move in a different plane, a different rhythm, a permanent reminder that Jupiter's system was built not just from orderly accretion, but also from acts of cosmic theft and destruction. Yet this gravitational choreography extends to a pair of moons locked in a perpetual, delicate exchange. Orbiting within the very heart of Saturn's rings, Epimetheus and Janus are 2 small, potato-shaped worlds engaged in one of the solar system's most elegant orbital dances. They are co-orbital moons, meaning they share essentially the same path around Saturn, separated by only about 30 miles in altitude. This tiny difference is the key to a remarkable gravitational ritual that repeats every 4 years. As the inner moon, which orbits slightly faster, begins to catch up to the outer one, their mutual gravity does not pull them into a collision. Instead, they perform a graceful swap. The inner moon tugs the outer one inward, while the outer moon pulls the inner one outward. They effectively trade orbits, and the chase begins again in the opposite direction. To visualize this, picture two runners on a circular track. The faster runner from behind doesn't crash into the slower one, but instead they gently exchange lanes, causing the former leader to fall behind. This is called a horseshoe orbit because if you were to plot one moon's path relative to the other from a fixed point, it would trace out a shape like a giant horseshoe, with the two moons forever approaching and then swinging away from each other without ever meeting. It is a stable, repeating cycle of gravitational courtesy that has likely persisted for billions of years. The moons themselves are battered twins, each about 70 to 90 miles across, resembling lumpy potatoes more than spheres. Their surfaces are ancient and heavily cratered, a testament to their age and the relatively calm nature of their shared orbital highway. They are likely rubble piles, fragile collections of ice and rock barely held together by their own weak gravity. Their similarity in size and composition suggests they may be fragments of a single larger moon that shattered long ago, its pieces finding this exquisitely balanced partnership in the aftermath. The dance of Epimetheus and Janus is a masterpiece of celestial mechanics, a proof that even in the apparent chaos of space, stability can emerge from a perfectly timed, gentle tug. Deep within Saturn's magnificent rings, two tiny worlds wear impossible costumes. Pan and Atlas are the solar system's flying saucers, moons that defy the very idea of what a moon should look like. They are not spheres, not even lumpy potatoes. Instead, they are shaped like ravioli or perhaps giant cosmic hats with bulging equatorial ridges that give them a bizarre, flattened appearance. These ridges are not made of the same material as the moon's cores. They are delicate skirts of fine, icy ring dust accumulated over countless millennia. Pan, the innermost, orbits within the Inca gap in Saturn's ring, while Atlas hugs the outer edge of the same bright ring. Their shapes are a direct, visible consequence of their unique addresses. They are shepherd moons born from and sculpted by the rings themselves. As these small moons travel through their orbits, their gravity gently herds the countless icy particles around them. They sweep clear, narrow pathways, creating the gaps we see. But the interaction is a two-way street. The ring particles, in turn, are drawn toward the moon's equator by its own weak gravity. Imagine a moon moving through a dense, slow-motion blizzard of ice. The snow doesn't just fly past, it sticks to its middle, building up layer after thin layer along the equator. This process, called accretion, has created those stunning, smooth ridges, making Pan and Atlas look as if they were spun on a potter's wheel while wet with ring material. The Cassini spacecraft's breathtaking close-ups revealed these shapes in astonishing detail. Pan's ridge is so sharp and symmetrical it appears almost artificial, a perfect belt of bright dust around a darker, rocky core. Atlas is even more exaggerated, with a ridge so wide and flat it resembles a classic science fiction flying saucer more than a natural celestial body. These are not static sculptures, however. They are active participants in the ring's dynamics. Their gravity creates not just gaps, but also wakes like the ripples behind a boat within the ring material on either side of their path. They are cosmic custodians. Their very forms a ledger of their long, patient work of organizing the chaos of Saturn's most stunning feature. To see them is to witness a moon in the act of becoming, a world whose final shape is being written by the glittering environment it calls home. The delicate architecture of Saturn's rings relies on invisible architects. Just beyond the main bands, a single, narrow, and impossibly active strand of ice orbits the planet, the F-ring. This is not a serene, static halo, but a constantly twisting, braiding, and kinking ribbon of light, and its frenetic dance is choreographed by two tiny, gravitational puppeteers, Prometheus and Pandora. These are shepherd moons, their sole purpose to confine and sculpt this most dynamic of Saturn's rings. Prometheus, the inner shepherd, orbits just inside the F-ring while Pandora patrols the outside. Their gravitational tugs act like celestial fences, herding the countless icy particles and preventing the ring from spreading out and dissipating into space. But their herding is far from gentle. As they pass by the ring in their slightly mismatched orbits, they reach out with their gravity and grab handfuls of ring material. This creates dazzling, temporary structures within the F-ring itself. You can see bright, dusty streamers pulled from the ring's core, deep channels carved into its edge, and even braided patterns where gravitational resonances twist the icy particles into knots. The Cassini spacecraft witnessed Prometheus performing this theft in real time, its passage leaving a dark, scooped-out gash in the ring that slowly healed over the following orbit. Both moons are themselves irregular and potato-shaped, mere rubble piles of ice and rock, but their influence is immense relative to their size. Their orbits are not perfectly circular, so with each pass, they interact with the ring at a slightly different distance, creating a constantly changing tapestry of perturbation. Visualizing this is to watch a celestial loom in action. Time-lapse images show the F-ring as a living entity, its bright core writhing with kinks and jets, while the faint, ethereal strands drawn out by the shepherds flutter around it like cosmic banners. This is a system in a perpetual state of gravitational conversation, where two small, misshapen worlds use their subtle pull to conduct an orchestra of ice, writing patterns of stunning complexity on a canvas 62,000 miles wide. Far beyond the orderly orbits of the planets, in the deep freeze of the Kuiper belt, a single moon redefined our solar system. Dysnomia is the small, dark companion to the dwarf planet Eris, a world so distant it takes over 550 Earth years to complete a single orbit around the Sun. The discovery of this tiny moon was not just about finding another satellite, it was the key that unlocked a cosmic controversy. For years after Eris was spotted in 2005, astronomers knew it was a significant object, but they could not accurately determine its mass. Without knowing its mass, they could not be sure of its true size relative to Pluto. The presence of dysnomia changed everything. By carefully tracking the moon's slow, stately orbit around Eris over many years, scientists could apply the laws of orbital mechanics, the same rules that govern planets around the Sun. The time it took dysnomia to complete one circuit and the distance between the two bodies allowed them to calculate the total mass of the system with precision. The result was a shock. Eris was 27% more massive than Pluto. This measurement was the final, definitive piece of evidence that proved Pluto was not a unique anomaly, but one of many substantial icy worlds in the Kuiper belt. That single data point forced the International Astronomical Union to create a new category, dwarf planet, and reclassify Pluto in 2006. A tiny, dark moon, barely visible from Earth, had rewritten the textbook. Dysnomia itself is likely a captured object, a Kuiper belt denizen that strayed too close to Eris in the distant past and was gravitationally ensnared. Its surface is thought to be incredibly dark, coated in the same complex reddish organic sludge called tholins that colors many outer solar system objects. Artists' concepts paint a haunting scene, Eris, a brilliant, almost star-like point of reflected sunlight, with dysnomia as a faint, dark speck against the profound blackness, both illuminated by a sun so distant it appears only as an impossibly bright star. Studying this faint pair is like reading a fossil record of the solar system's earliest days. The Kuiper belt is a cosmic deep freeze, preserving primordial material largely unchanged for 4.5 billion years. The orbits, compositions, and pairings of objects like Eris and dysnomia tell us about the conditions and collisions that occurred as the giant planets formed and scattered debris outward. Each measured mass, each observed orbit, is a clue to the gravitational choreography that built our planetary neighborhood. Dysnomia's silent dance, measured across light hours of space, reminds us that sometimes the smallest witness holds the answer to the biggest questions. Deep in the frozen expanse where Eris and Dysnomia trace their slow circles, another pair of twins mirrors a more famous couple. Orbiting the Sun in the cold quiet of the Kuiper belt, the dwarf planet Orcus and its moon Vanth form a binary system that is a haunting echo of Pluto and Charon, a reflection seen across a much greater distance. Orcus itself is a world of contrasts, often called the anti-Pluto because its orbit keeps it on nearly the opposite side of the Sun from its more famous counterpart. But the true kinship lies in its companion. Vanth is remarkably large, estimated to be about a third the diameter of Orcus itself. This proportion is strikingly similar to the Pluto-Charon partnership, suggesting a shared history of formation through a colossal, ancient impact. The two systems are like siblings separated at the solar system's birth, one finding fame in the relative inner realm and the other dwelling in profound obscurity. Their synchronous dance is locked, each forever showing the same face to the other, a frozen embrace across thousands of miles of space. The discovery of Vanth in 2005 was a quiet revelation. Finding such a substantial moon around a relatively small, distant world told astronomers that the Pluto-Charon system was not a one-time fluke. Large binary partnerships, it seems, might be a common outcome in the chaotic early Kuiper belt. When sizable icy bodies collided in those formative years, the debris didn't always coalesce into a single new world. Sometimes it found a stable balance as two, forever bound by their shared catastrophe. Picture them side by side, the Pluto-Charon pair and the Orcus-Vanth duo. Pluto with its bright heart and complex atmosphere, Charon with its dark polar cap and vast canyon. Orcus, from limited data, appears to have a bright surface of water ice, while Vanth is significantly darker, a deep charcoal gray. This contrast hints at a fascinating possibility. Perhaps Vanth is covered in the same dark organic tholins that stain Charon's pole, or maybe it is made of different, primitive material entirely, a captured object rather than a co-formed partner. The difference in their reflectivity would make for a stunning visual, a bright, icy primary and a dark, somber companion, spinning together in the perpetual twilight at the solar system's edge. Each new binary system we find in this distant reservoir, like a series of distant, matched pendulums swinging in the dark, rewrites our understanding of how these frozen worlds came to be and how often violence gives birth to partnership. But the Kuiper belt holds a system that looks like the result of a cosmic billiard shot gone perfectly wrong. Haumea is not a sphere, it is a rapidly spinning egg, a dwarf planet stretched into the shape of a flattened football by its own dizzying rotation. It completes a full turn on its axis in less than 4 hours, a day so short it would fling loose material from its surface into space. This bizarre shape is just the beginning of its strangeness. Haumea is also sheathed in a bright, crystalline coat of almost pure water ice, and it is encircled by a faint, dark ring, a delicate halo in the deep freeze. And attending this spinning, ringed egg are two moons, Hioka and Namoka, a celestial family born from a single, shattering instant. The story of their creation is written in their path. Both moons orbit in the same plane as Haumea's equator and its ring, and they follow nearly circular paths. This precise, aligned geometry is the classic fingerprint of a giant impact. Billions of years ago, another sizable Kuiper belt object is thought to have slammed into the proto-Haumea. The collision was catastrophic but not a direct hit. It was a powerful, glancing blow that sent the dwarf planet spinning like a top, stretching its still pliable form into that elongated shape. The impact also vaporized and shattered a tremendous amount of icy material. Some of this debris was flung into orbit, where it quickly coalesced to form the two moons, Hioka and Namoka. Any remaining dust and fragments that did not clump into moons settled into the stable, thin ring we see today. Visualize that moment of creation, a silent, slow-motion impact in the absolute dark, a flash of light as two icy worlds meet, and a spray of glittering fragments arcing outwards, some destined to become moons, others to form a permanent summer circle. The moons themselves are distinct characters. Hyperion, the larger outer moon, is about 250 miles in diameter and is also covered in pristine water ice. Its surface is so bright it suggests constant refreshment, perhaps from microscopic ice particles knocked off Haumea itself. Nemoka, the inner moon, is smaller, darker, and follows a more eccentric, tilted orbit, a sign of the complex gravitational interplay within this young family. From the surface of either moon, the view would be surreal. Haumea would loom not as a disk, but as a vast, tumbling egg, its ends sweeping across the sky with every rapid rotation. The faint ring might appear as a thin, dark line cutting across the giant's middle, barely visible except when backlit by the distant sun. This entire system, the spinning dwarf, its ring, and its two moons, is a perfectly preserved fossil of a single, defining collision, a clockwork set in motion by violence and still ticking in the silent dark. But our solar system is just one island in a vast cosmic archipelago. For every strange moon orbiting Jupiter or Saturn, there could be millions more circling planets around other stars. These are the exomoons, the final frontier in our search for celestial companions, and their discovery would rewrite the story of where life could exist. The challenge of finding them is almost unimaginable. We have detected thousands of exoplanets, but they appear to us only as a periodic dimming of their star's light, a tiny shadow passing by. Spotting a moon's additional, even fainter shadow within that planetary dip is like trying to hear a whisper inside a shout from thousands of light years away. Yet astronomers are listening. One of the most tantalizing hints came from data on the exoplanet Kepler 1625b, a gas giant orbiting a sun-like star. When scientists looked closely, they saw anomalies in the light curve, subtle dips and timing shifts that could be explained by the presence of a massive moon, perhaps the size of Neptune, trailing its planet. The evidence remains controversial, not yet confirmed, but it is a beacon in the dark, a signal that the hunt is yielding its first fragile clues. The method relies on exquisite precision. As a planet transits its star, a large moon could cause a second, smaller dip in starlight just before or after the main event. Or the moon's gravity can tug on its planet, causing the planet to wobble slightly, making its transit begin a few minutes early or late. Detecting these minuscule effects pushes our telescopes and algorithms to their absolute limits, but the reward for success would be nothing short of revolutionary. Imagine a gas giant like Jupiter, but placed gently within its star's habitable zone, that Goldilocks region where temperatures could allow for liquid water. Such a planet itself would be a swirling ball of gas, utterly hostile to life as we know it. But orbiting that giant could be a large, rocky moon, a world like Europa or Triton, but warmed by the light of its own sun. This exomoon would have a double energy source, tidal heating from its planet and sunlight from its star. It could possess a thick atmosphere, deep oceans, and continents. It would be a world with a breathtaking sky dominated by the colossal, banded face of its primary planet, hanging forever in one place or moving through phases in a strange, swift cycle. Finding just one such place would explode the concept of a habitable zone. Suddenly, billions of star systems with giant planets in temperate orbits become potential homes for life, not on the planets but in their skies. The search for these distant moons is a search for the ultimate cosmic mirrors, reflecting back at us the profound possibility that every strange and wonderful story told by our own solar system's moons is being retold in infinite variation around stars we have yet to name. These 25 worlds are a testament to a universe built not on order but on glorious chaos. We have toured volcanic hellscapes forged by a planet's gravitational fist and peered beneath frozen shells into oceans holding secrets older than life itself. We have met captured wanderers tumbling in backward orbits and witnessed delicate moons sculpted from the dust of their own rings. Each one, from the fractured face of Miranda to the doomed spiral of Triton, is a moon that by every old, quiet rule of astronomy simply should not exist. Yet here they are, not as errors but as evidence. Their very strangeness is the key that unlocks the true history of our solar system, a story written in collisions, captures, and relentless gravitational dances. They prove that our cosmic neighborhood is not a still life, but a dynamic, evolving masterpiece where every crater, every plume, every backwards orbit is a sentence in a chronicle of violence and wonder. And the story is far from over. Our curiosity is now crafting the next chapter. Spacecraft like Europa Clipper will soon skim the plumes of that icy moon, tasting its hidden sea for signs of chemistry that could hint at life. Dragonfly, a robotic rotorcraft, will one day soar through the thick, orange skies of Titan, landing on its organic dunes to read the recipe for a world so like our own, yet so profoundly alien. These missions are our way of reaching out to these impossible places, of asking the questions their very existence demands. So tell me, on this tour of cosmic anomalies, which strange moon captured your imagination the most? Was it the hidden ocean of Enceladus or the two-toned mystery of Iapetus? Share your thoughts below, and if you enjoyed this journey to the edges of our understanding, be sure to subscribe. The universe is filled with wonders that defy expectation, and together we will keep exploring them all.